Okay, let's think about the following example. Find the two-dimensional vector whose direction is 30 degrees from the x-axis. Counterclockwise. And whose magnitude is is 6. Okay, so let's think about what this means by drawing a picture. So here's the x-axis, and you're going counterclockwise 30 degrees. So here's 30 degrees. And you're trying to find a vector whose length is 6. All right. How do we do this? Well, first of all, what you can do is you can think about the unit circle, because on the unit circle I know from pre-calculus lessons that what this coordinate is. And then if I know that coordinate and I know this vector, because that coordinate is the vector itself, you just have to change the notation from parentheses to angled brackets. And then you just have to multiply it by 6 because you want to resize it to this vector. Okay? All right, so what is it? What's the coordinate of this? What comma what? All right. It's cosine 30 degrees, comma, sine 30 degrees, right? We all know that from pre-calculus when we first learned trigonometric functions on the unit circle. This is what we learned. Now you need to remember what cosine 30 and sine 30 degrees is. And let me show you what I like to do. I like to do it by drawing the graphs. So sine curve looks like this. Cosine goes like that. Well, you can just choose to memorize it if you but if you don't want to memorize it, this is something you can do. This is 90 degrees, right? It's 90 degrees. And in between 0 to 90 degrees, you have 3 special angles: 30, 45, 60. 30, 45, 60. And whenever you have angles between these quadrants, so this first quadrant, second quadrant, third quadrant, fourth quadrant, the value of sines and cosines, they always choose among these 3 values. And it's easy to remember because it's easy to remember if you see that they're of the same shape. And if you know the shape, then all you have to remember in addition is that it's 1, 2, 3. This one may not be familiar to you because the square root of 1 is 1, and therefore usually people write as 1 over 2, right? Now if you write it like this, then you know that this is the smallest value, this is a medium size, that's a large. This is small, medium, large, just like the coffee that you order in the morning, right? And then sine 30 degrees is this one. Among these 3, is this small, medium, or large? It's a small size, so sine 30 is 1/2. So this must be 1/2. Okay, and then here, this is the cosine graph. For the cosine, it's large, medium, small, right? So what's cosine 30 degrees? Large, medium, or small? Which one? It's a large value. And therefore, among those, radical 3 over 2. So if you do this, then it's not hard to remember. See, graphs are easier to remember than numbers. So if you have these memorized, then it's going to stay with you until the final exam. If you just have these values memorized, then it's very easy for you to forget it during the exam, and that's not good. Okay, so try to do it this way. All right, so anyways, this is what we have. And therefore, we know that if you have a unit circle, and this is 30 degrees, what is this vector? This vector is, in angled bracket, what is it? What, come on, what? I have it here. What is it? Radical 3 over 2, comma, 1 over 2. Okay. All right, so we're almost there. Now what do we have to do? What's the length of this? It's 1, because this is a unit circle. Unit circle have a radius 1, so this length is 1, but we want a vector whose magnitude is 6. So what do? Multiply by 6. So we take 6 times this to get the answer. So answer is 6 times radical 3 over 2, comma 1 over 2. And therefore this is 6. Okay. 6 and 1/2, they reduce, right? So 2 reduces 6 to 3, so it's 3 radical 3, comma 3. So that's the answer. Now, vectors whose length or magnitude is 1 is called the unit vector. By the way, sometimes I'll say the length of a vector, sometimes I'll say size of a vector, sometimes I'll say magnitude of a vector. It all means the same thing, magnitude. All right. So you probably understood from the solution that when you have a vector with length 1, it's very convenient to use it. Right? So definition, a vector whose magnitude is 1 is called a unit vector. Whenever you see the word unit vector, you should understand that the magnitude is, what's the magnitude? 1. Whenever you see the word unit vector, you have to understand that it's a vector with size 1. Okay. All right, so here's the next example. Let P be the point -1, 2, and Q be the point 3, -2. Okay. A, find PQ. B, find the unit vector in the direction of PQ. So we're kind of trying to do the opposite of the first example that we did. So in the first example that we did, we first found the unit vector and multiplied by something to get the vector that we wanted. Here we find the vector that we want first, and then we have to resize it to make the magnitude as 1. So that's our goal. Okay, so solution. What do you do for the first one? Part A. PQ is, what do you do? Terminal minus initial. That's the formula, right? So you do terminal, which is 3 comma negative 2, minus initial, which is negative 1 comma 2. And therefore it's 3 minus negative 1, which is 4. Negative 2 minus 2, which is negative 4. That's what we have. All right, so that's the answer to A. Now for B, if you have this vector 4 comma negative 4, I want the unit vector u to be same direction as 4 comma negative 4, but okay, before we try to reach that conclusion, what's the magnitude of this vector? What's the magnitude? What's the formula for the, I didn't talk about the slope, it's not the slope. What's the magnitude? What's the formula for magnitude? Square root of 4 squared is 16 plus 16. Negative 4 squared is also 16. So this is square root of 32. The 16 times 2, 16 can come outside of the square root as 4, so it's 4 radical 2, right? So because this vector has the length 4 radical 2, it's not a unit vector. Do we need to enlarge, lengthen it, or do we need to shrink it? Shrink. We need to shrink it in order to make it as a unit vector, right? So how do you make it shrink? Divide it by its size. Okay, if you divide it by its size, like if you divide it by 2, the length will be halved. If you divide by 4, it will be a quarter of the length. If you divide by 4 radical 2, what was 4 radical 2 will have the length 1, right? So what you need to do is take this vector and divide it by its length. Okay. So u, the unit vector in the direction of PQ, is this divided by its length, which is, we already computed here, 4 comma negative 4, divided by 4 radical 2. And then if you reduce 4 and 4, you get 1 comma negative 1 divided by square root of 2, divided by 4 top and bottom. And then this is 1 over square root of 2, negative 1 over square root of 2. And if you multiply square root of 2 top and bottom, you get square root of 2 over 2. I have to rationalize the denominator. So that's how you resize it to make it into a certain length.